Hello there, welcome back. In this lecture, we'll create the hvac pipes in the project. So let's start. First of all, it is important to understand that there are two ways in which the pipe designing can be done in Revit. The first one, where we can do the designing by the simple basic method of hvac that uses charts and tables. So this is a very basic method. The other method is where we can draw pipes of any dimensions in the Revit, and later on we can do pipe designing with the help of Revit software. So that way, whatever dimensions you have taken, Revit will adjust those dimensions according to the flow. So the second method is actually something that we'll be discussing in the later lectures in this module. As of now, I'll discuss how you can do the actual designing of the pipes using basic charts and tables. Now, before we do that, first of all, let me show you something. If I go to the chiller, so there we have the option to draw pipe for chilled water supply, and from here we can create a pipe for chilled water return. Okay, now let's try to draw a pipe from here. So click on this and then we can draw the pipe. What is important to note over here is the diameter. Here you can see by default it is creating 100 mm. That you can also see when we select the chiller. Over here it is mentioned as 100 mm out, 100 mm in. Now if you remember, we have chosen chiller of 246 kilowatt, and for us the value was somewhere around 230. So we have selected chiller with slightly higher capacity. But that's not an issue. We can definitely draw pipe of 100 mm. But let's say, is there any chance with the help of which we can create pipe of lesser dimension, or according to ASHRAE standards, what dimension of pipe it is going to allow in this case? So that we have to check. First, we need to go to the project browser and look for the analysis report. Go to table of contents and then equipment summary. Okay, over here, go to the section of pumps. Here you will get the water flow. This is 0.005977 meter cube per second. If you convert this value to GPM, this will be around 95 GPM. Now, why I'm telling you to convert this to GPM? Because the chart that is available to us is in GPM. So I'll show you that. Okay, so this is the chart that will be used to determine the pipe diameter. Here you can see the flow, this is the friction loss, and this is the pipe size. This is basically these lines which are in black and slanted, and one more line we have which are in red. These will determine the velocity of the flow. Now in our case the flow was 95 GPM. So let's look for that. Here we have 80, here we have 100. So what we can do, we can actually select 100 because that is very close to 95. Pipe will be slightly over designed, but that doesn't matter a lot. So draw a line over here. Now this line intersects the pipe size line over here, next over here, then over here, then over here, then over here, and so on. So these are the options available to us. So what we can do for this flow, we can actually select a pipe which has the diameter of 5 inches. You can see. And in this case, what is the friction loss? So you can imagine a line running down from here to friction loss line. So this is 0.2, which is a very good value. But let's say we don't want to go for the 5-inch pipe. Let's see if there is any option which will give us a lesser diameter pipe. So the next option is this one. This is a line corresponding to 4-inch pipe. So now from here, imagine a line running down to the friction loss. So this is around 0.6. As of now, we already know the ASHRAE standards allow us to stay below this value. We cannot exceed the friction loss 4 feet of water for 100 feet. So we have to be in this region. Okay, so this pipe and this pipe both lies in this region. So both can be selected. But for cost economics, we try to choose a pipe with least diameter possible. Let's look for the next option. This is the next option. This is a line corresponding to 3.5 inch pipe diameter. So 3.5 inch, if we imagine a line from here to here, this is also possible to be selected. Okay, let's look for the next one. The next one is the line corresponding to 3-inch diameter. And if we imagine a line from here, it will be somewhere around this region. What is important to us that this point should be within the value of 4. So this can also be selected. Now, if we select the next value, which is 2.5-inch pipe, you see we are going beyond the value of 4. So in this case, the pipe cannot be selected according to ASHRAE standards. So the optimum value of pipe diameter in this case is 3-inch pipe. And as you know, 3-inch is approximately equal to 75 mm. So now let's go back to Revit. So go to the floor plan. Here by default it was 100 mm, but with the help of pipe designing we have determined that it can be 75 mm. That is the best possible value. So what we'll do, we'll try to take a value close to 75. So let's click on this. And over here we can see that we have a value of 80, which is very close to 75. So again, this can be slightly over designed, but it works perfectly. So let's select this value and then we can create pipe. So I'll just create pipe till this part. Why, I'll tell you. This is for the supply and we can create for return from here. Okay, come out of the command. Now, if I select this pipe, you will find that this is one of the type chosen, the standard type, because while drawing the pipe, this was the option selected by default. In case you want to change this, you can definitely do so. So you can either go for any of the options, or if you want to have any other pipe, you can definitely go to pipe routing preferences and create a pipe of your choice and select that value from here. So as of now, I'm going with the default values. So let's press escape. So what we have done, we have actually determined the pipe diameter based on ASHRAE standards. The next thing that is important to understand is we have to connect these pipes with the pumps. Over here you can see these are the secondary pumps. They will carry water from the chiller to the building, and from the building the water will be carried from these primary pumps to the chiller. So we need to connect this pipe with the inlet of this pump and this pump as well. Now it is not for sure that the elevation of this pipe is going to be same as the elevation of the inlet of this pump. This has got elevation of 483. Okay, now we'll try to check the elevation for this one. First we need to create a section view. Okay. All right, so let's go to this, double click, and there we have it. So zoom it. Okay, you can change the detail levels and visual styles if you want. Now what is the elevation of the inlet? Now click on this and draw a pipe from here. We're not actually drawing, we'll just check the inlet elevation. So you can see over here, now it's changed because I've changed the arrow position. Now when I bring the arrow back to its original position, I want you to focus the value over here. Okay, now you can see the middle elevation is 272. So now again, let's go back to this. Is the elevation of this pipe 272 mm? No, we know for that. So what we can do, we can continue creating pipe from here. Draw pipe. But this time we are going to change the elevation to 272. And now you can keep drawing the pipe till here. Okay. Now you will find that some fittings are automatically taken over here. We can do the same for this case as well. Right click, draw pipe, change the elevation. and then click. Now let's go to the 3D view and see what we have drawn. So this is what we have done. Now I also want you to focus over here. The pipe that we have drawn has the diameter as 80 mm, and by default the chiller was giving us 100 mm. So you can see a connection over here. This is a reducer which is basically connecting 100 mm dia pipe with 80 mm dia pipe. Alright, so now we have determined the pipe diameter, and also we have determined the middle elevation of the inlet of the pump. Now again, let's go to the plan view, and now we need to go to the section view. So double click. So this is the pipe we already have. What we can do, click on this. From here, create a pipe. Now by default you can see this is having a diameter of 40, so you can continue with this, or if you want you can have the diameter of the pipe that is coming from the chiller. That way the connection looks better, the flow is smooth, and there are lesser number of fittings to be used. So we can change this to 80 and connect with the pipe coming from the chiller. Okay, let's go to 3D and see what we have created. Alright, so we have connected the chilled water supply pipe with the secondary pump. Now we can again connect in the same way as we have done for this one. What we can do, we can take this section view from here and shift it a little over here, and then go to the section view, either double click here or go to section, and here you will find that pipe and the pump, and you can make the connections again. So we'll do that. Select this and take this value to be 80. Click. Now let's go to 3D view, and now you can see these two are connected. We could have also connected them in other way, like I'll tell you. Let's undo this and select this pump and connect into which of the two openings you want to connect. We want to connect the inlet, so select the option of liquid in over here. This inlet we want to connect with this pipe. Just click. There you have it. But in this way what will happen, you will get a different diameter pipe. That control you won't have. Maybe you can definitely change the diameter after creating it, but the fitting is going to stay over here. So this is what I don't generally recommend. If you create with the basic way, you have much control. So let's undo this. All right, so it seems some amount of problem, but that's not an issue. We can definitely create it again. Okay, so we have rectified the error and we have fixed it. Actually, when we undid the command, the position of the pump got shifted and that was causing the problem, but we have fixed it. So let's select this again and click on this, change the diameter to 80 and draw the pipe. So there we have it. Go to 3D. So this is what we already have. So all right, we have connected the secondary pumps with the chilled water supply line. Now let's connect these two pumps. So bring this section view over here and try to place it in such a way that we see the pump and we don't include anything else. Go to the section view. Then again select the pump. Select this. Change the value of diameter to 80 and connect with the pipe. Again go to the plan view, shift this, go to the section view, and again do the same. Now obviously there are a lot of options in which you can create this, but the way I'm telling you is something that will work always. Some or the other method will work just fine in most of the time, but this method will work always. So what we have done, we have created all of it. All right, so now what next we have to do? We have to draw the pipes from the outlet of the pump, and these pipes will go inside the building. So let's do that. First, let's draw outlet from this pump. Okay, so this was the inlet. Now outlet also you can have the same value of diameter. It's not a problem. You can have the value of 80, and the height up to which I'm taking this, keep it to be 1200. You can obviously change as per your convenience, but the value of 1200 will work just fine. So click, then you get a warning that Revit could not find a matching pipe segment, but that's not a worry because we haven't finished creating it yet. Now, if you want, you can align this on top of the pipe, which is on the inlet of the pump. But at this point of time, I will not suggest that because that will block the view of the below pipe. So let's have some amount of clearance and draw pipe from here. Okay, so this is the outlet. Go to floor mat. Over here, you can see we have outlet till here. Click this and then right click and then draw pipe. You see the value of 80 is taken automatically and click. Later on, we'll continue with the creation of this pipe. As of now, just click. So if you want, you can have a pipe in this way, or what else you can do? You can actually upgrade this elbow and create a pipe on the other side. Obviously, we have to cap this end, so that we'll be doing later on. As of now, why I've drawn this, because this will help in case if there is any change brought into the system later on. This can be easily connected to other pumps. So that's why we have this kind of design. Okay, so we have connected the outlet pipe of this pump with the header. Let's do the same for this pump. Select the pump, select the outlet position, change the value of diameter, and make sure you get this line. And then you get this endpoint snapped and then click it. And in 3D, you can see we have made the connection. So this is the inlet, this is the outlet, and this outlet is connected with the header. In the same way for this pump also. Okay, so as far the design looks good. Now try to do the same for the other two pumps. Go to section. This is the outlet. If you remember, we have kept the value to 1200. And we can have the pipe till 500. Okay. Now again go to the floor mat, and then we can get this pipe, which is the outlet pipe. Okay, so right click on this, draw pipe, and the value of 80 is already taken, and click. Again, you can upgrade this elbow. So right click, come out of the command, click on this fitting and upgrade this. So now we have a T and draw a pipe from here. There we have it. So now if you want to shift these two pumps so that the pipes look symmetrical to the ones on this side, we can actually select these two pumps. With the help of arrow keys, you can shift them. Also, you can select this pipe With the help of arrow keys, you can shift these. If you have the exact dimension, you can take that. In general, you don't get exact dimensions for this case. So what we have done, we have made necessary changes. All right, so we have aligned, so everything looks good. Now what we can do, for the last pump, we have to draw the outlet. So again, go to the section view. This is the pump, select this, same process. Make sure this is 80. Don't forget to check the line. So now we have created all of it in 3D view. Now you can visualize. Okay, so this is the chiller, and this is the outlet, this is the inlet, and this is getting connected with the secondary pump and with the primary pump. All right, so we have made connections till here. What we can do now, we don't need this section view, so let's delete this and continue with the design. You can also cap this in case you want. So it's better to cap it over here. So select the pipe and cap open ends. Like this one, and cap open ends. So these two ends are capped. Now here also the pipe is getting terminated, so we can select both of them, and I think we selected a lot. So just select the pipe, cap open ends, select the pipe, and again cap open ends. These terminals are now capped. Okay, now what we can do, these are the runs, these are the headers that will actually go to the building. So we need to proceed with the design. Now from here, you want to have the same elevation, you can continue with that. If you want to change the elevation, you can do so as well. So in this case, what I'm gonna do, from here I'll create pipe, but this time I'll just keep the elevation to be 0. Generally from here the pipes are underground, but as of now I want you to see the pipe during our full design. So that's the reason why I'm keeping the visibility and making the elevation 0. Generally the elevation will have some minus value. So let's draw the pipe till here. Now in the same way, draw pipe from here. Come out of the command, select the pipe, right click, draw pipe. Zoom out, and we can take the middle elevation to be 0. Now also sometimes what designers prefer, they just make this pipe close to this one and then you can have the run. So that is also one way in which you can do the designing. I've selected this method. Now over here you can see the new fittings that have been brought into the system. So this is the pipe that we have afterwards. Okay, now what we can do, we have to continue creating this. So select this one, right click, draw pipe, and we can go till here. Come out of the command, select this, right click, draw pipe, and click and escape. Okay, so this is what we have done till now. Now over here, if you see in this project, there are windows very close to the pipe. Now what I'm trying to do, will be taking the pipe from here vertically up. But in that process, we don't have much space over here, and there are chances that we can make these pipes to be running in front of the windows, which is generally not recommended. So what is the best option to avoid this? You can take one of the pipes from here and the other pipe, rotate this and take it above from here. That's something you can do, but at this stage of time, since we are learning new, so we'll just take these two pipes to be vertically upwards from here. So even if it hinders or blocks the view from the window, that is not going to be a problem at this point of time. But this is something you have to take care of when you're doing the final project. So anyway, we'll continue drawing this. So let's go to floor mech again, and this is what we have done. Okay, now what we have to do, we have to go to the section view and create a section view over here, and just bring this to whatever extent we want. So let's say I want to be till here. So now double click. Okay, so there we have it. We'll change the detail level, and you can see the two pipes. If you have any confusion, select one and then look for, this is the hydronic return, and this one, and then select the other one. This is our hydronic supply. Okay, so we'll just change this to realistic. All right, so now what we can do, we know in this view that this is extended beyond, so we'll take this from here to here and then move it vertically upwards, or you can also take it vertically upwards from here as well. First, it's better to draw this pipe because this is closer to the wall. So bring this section view over here. Now what we can see, we'll see the Hydronic return. Okay, so first we'll create the pipe for return. Select this. Now it is generally difficult in this case to do selections. So make sure you get the proper selections before you proceed. So this is what we have, and then this is the turning. So let's go over here. You see we have some space over here, but don't try to stretch it and draw the pipe because we already have the other pipe over here. So let's keep it over here, and later in case we want any change we can do that. As of now, don't worry for the obstruction and intersection. So make this move till the top floor. So you can draw till here. Later on we can change this obviously, and right click cancel, right click cancel. So this is what we have done. This is the pipe return. So we have drawn it like this. Now we'll draw the supply pipe. Now shift this, go to section view, and now you see we have some more space available over here, and we don't need to draw anything else beyond this. So what I can do, I can actually draw a pipe from here and extend it a bit so that we get some more space on the right side, and then draw till the top floor. Zoom out, and once you are there, zoom in and click. Now where it has to terminate, what will happen with the end of these two pipes, all those will be deciding later on. Now once we have done the drawing of these two pipes, what we can do, we can make necessary changes and shift them. So select, and with the help of arrow keys you can actually shift. Now see, there is no obstruction with the window, and these two pipes are fairly close to each other. Okay, now let's go to the 3D view, and this is what we have. We have a pipe running from the chiller to the pumps and then to the building. Alright, so this was all about the first part where we create pipings in HVAC network. In our next lecture, we'll continue creating pipes for each and every floor, and we'll connect these pipes with the indoor AHUs installed above the false ceilings. Hope you enjoyed the session. See you again in the next one.